Hi, welcome to this channel on magnetic energy technology principles applications. This video is about the changes coming to the ionosphere, and of course this is a very alternative information. This is based on a magnetic etheric model of the universe, technology from the past and present and everywhere. And yes, this is very weird information, but hopefully in a few years this information won't be quite so weird as it is now. So, let me see real quick. This is from 1985. The generating force of the ionic atmosphere is not produced by the calculative measurement of neutrons, but by the coexistence of energy within the structure of the universe. So this is a statement that's from a much larger conversation that revolves around the ionosphere and the changes that are going on and happening to our planet. And there's a reason why electricity is never really prevalent during the up cycles of like this solar system and this planet's kind of, we have the low vibration cycle, if you want to call it that, and the high vibration cycle. And electricity isn't really a prevalent technology in the high vibration cycle. And it's not just because it's primitive and it's highly destructive and it's very unenlightened technology. It's not because of those things. I mean, it is partly, of course, but it's also because there are changes in the ionosphere that make that type of technology very difficult to use, especially at the level that we're using it right now. And we've been getting kind of lucky or fortunate, humanity, for the last 100 years or so, with electricity being mass distributed the way it has been. And one of the things that scientists and people, what we take for granted, like the conditions on our planet and how our technology interacts with the energetic systems on our planet. And so this type of change that's coming to the ionosphere, this hasn't really been seen in recorded history from a conventional point of view, which is absolutely a terrible depiction of history and very inaccurate and everything else. And all that will change. We'll all get much more accurate information about what's really taken place historically on this planet for so much longer than conventional whatever. That's a side point wants to acknowledge. But so there's changes that are coming that are different than we've really seen in recorded history. And part of it is, if you look at like what's happening with the solar cycle, and when the Earth gets bombarded with the CMEs and we have the ionosphere becoming supercharged, this is a different, what's going to happen is a different process than that. That's really kind of an overload in the system, if you will, and a pressure in the system that's kind of like pushed upon the ionosphere, and then it does its whole process with aurora borealis and lightning and earthquakes and all this stuff to go through this whole process of channeling that energy out, especially because the system is quite unbalanced right now. But what we're moving into is an overall increase in the energy of the ionosphere that's created from after this pole shift, there will be a higher draw on the planet of energy, a more intense draw of energy. And so it's not that because the ionosphere is going to become supercharged basically during the high cycle, it isn't like we're going to have like a lot more lightning or anything. As long as the ionosphere stays balanced, everything will be fine, but it will just have a tremendous amount more of energy in it. And the point of that statement that I read is it talks about how systems are all open systems. And so the ionosphere is an open system that has energy going in and out of it at all times. And you could say it's the redistribution zone of energy on our planet, the distribution zone. And that's really critical because as more energy is fed into the planet based on the draw that's coming out of the planet, it creates this intensity in the ionosphere that has a tremendously negative effect on electricity. And so I'm going to try to get into some of how that's going to apply to different areas of our lives. A simple analogy would be like an orange, where if you have an orange that has just a small amount of juice in it, and you go to juice it versus an orange that's really juicy and has a lot of juice in it, it'll juice like crazy, and the ionosphere is going to become very juiced up, if you will. Now, if the system goes out of balance in that situation, like if it were right now, it would wreak a lot of havoc. There would be incredibly intense lightning, incredibly intense vortices, storms, tornadoes, hurricanes. And I mean, we have some of that right now, obviously, with the system balancing, but it would be much more ramped up than that. Now, here's the thing. From this model's point of view, which will hopefully be recognized in the next few years as being more accurate than the conventional model, but it's a conventional power generation is not done in a vacuum. It is not an isolated system. So if you have like a coal-driven power plant, a nuclear power plant, hydroelectric power plant, and so on, those power plants, when they generate, they're not really generating anything, but when they produce whatever you want to call it, electricity, they are tapping the ionosphere. Now they're tapping it improperly, and that causes a massive problem. But what's going to happen though is after this pull shift, the ionosphere is going to become so supercharged because there's so much more energy flowing through our planet that anytime you have like a power plant that's a conventional power plant trying to turn those generators, and then of course it's going to go on and on from there, they will become overloaded. So, and it'll, scientists are going to go, oh my gosh, the system has changed and it's, oh, what's happening? But it's always been this way. It's just that the ionosphere is going to have a lot more intensity to it. And so they don't recognize that they're tapping the ionosphere at this point, but it'll become very apparent that something has radically changed on our planet, radically changed with the ionosphere. It'll be very measurable with the magnetosphere and everything, and generating electricity, it will fry any conductor that's done at high voltage. And so that's really going to be a big deal because it's going to shut down electrical production as we know it. And so there's a lot of things that this has implications for. So if you look at like manufacturing, typical manufacturing that uses a lot of high voltage and a lot of wattage and all this, it's not going to be very possible to have it done in that fashion. But if you have a shielded building, and Faraday cages are going to become very commonplace all over, and shielded buildings, metal buildings, aluminum buildings, steel buildings, all kinds of things that are super grounded, you can still have certain manufacturing processes in those buildings, and that even use electrical equipment. So I mean, you can still have those to some degree as long as the voltage isn't too high. And so that's the key, is the higher the voltage that's being produced, if you want to call it that, the more the ionosphere will react and short out whatever's happening. Now, and engineers are going to try to figure out a way around this, and it's going to be very challenging. Now, for magnetic energy technology, this is a great thing. And so magnetic energy technology is going to love this increase in the boost in the ionosphere. And you could have magnetic energy technology running all over the globe right now, but it'll be even easier to tap the ionosphere because it doesn't force the extraction. It draws the extraction, like it creates an attract stream from the ionosphere and then returns that energy. So it continues to propagate balance in the system and balance in the ionosphere, whereas electricity does not do that. So with magnetic energy, we're looking at like ions and neutrons. We're looking at the flow of ions through the conductive use of neutrons. And so we are looking at a balancing of the system. Electricity, the focus on electrons, creates a tremendous amount of problems. So when we get into manufacturing, high voltage type of manufacturing is going to become pretty much very, very difficult to accomplish. The transmission of electricity along wires is going to be very difficult to accomplish, if not impossible, because those wires would need to be so extraordinarily shielded and protected, and that's going to be difficult, if not impossible, to accomplish. So Now, there's some good news with this, I think, and part of that is like when you have low voltage technology, like let's say the internet and like our cell phones and our laptops and all of that, if it's handled properly, and even like with solar panels, if they have a low amount of output, the low voltage technology is relatively safe from that because it doesn't attract a lot of attention from the ionosphere. And so like a low voltage, like, our typical electronics and the internet, there probably still will be a form of the internet around that we, and through a lot of companies, they'll all be on this immediately on how to keep it going. And it's going to be, as long as they stick to low voltage output and low voltage transmission and low voltage this and low voltage that, the problem won't be so bad. Now, if you can go to like fiber optics, that's fine, and it's not really going to create a problem. That won't be a big draw. It's the problem is wherever voltage enters and higher voltage enters into the system. Now, obviously, magnetic energy manufacturing at that point will take off like crazy because it'll be very obvious that magnetic energy technology is really is where we need to go based on the changes that have taken place, and that manufacturing is light years beyond our conventional manufacturing, so that can change the world essentially almost overnight. Now, satellites are going to be interesting. So if satellites survive this current solar cycle that we're in, with solar flares and the ramp up of the cycle that we're just getting into right now, if satellites can survive all of that, when the ionosphere, and they can survive the pole shift and all that, and with the changes that are going to be happening, when they go to, if we go to communicate with them, this new ionosphere, if you want to call it that, it will be very difficult to have communication with satellites from a conventional point of view. Now, obviously, magnetic technology loves communicating in that environment, and it will love communicating through the ionosphere no matter what the conditions are. But from an electrical point of view, it could be very difficult to have any type of communication with satellites through the ionosphere. Now, the same thing goes with like conventional rocket technology and missile technology, military technology. Any of that type of technology that incorporates high voltage electrical technology is going to have a very difficult time. So rockets will have a very challenging time just getting through the ionosphere. And without incredible shielding, really it's going to take magnetic energy type of shielding. So we're talking about like neutral magnetic pulsing and then the redistribution and channeling of the ionospheric energy around that surface of that rocket. Otherwise, all the components on it are going to be completely fried when they try to go through. And there's been some examples of that have happened just recently with solar flares charging the ionosphere and hurting rockets. And they're like, what's going on? Well, that's probably what's happening, but it'll be consistent across the board. It'll be more intense with the new ionosphere. So now, as far as like extraction of oil, like our whole oil-based economy, any type of drilling and all that requires the heavy-duty motors, the heavy-duty like voltage and everything that's used in that's all going to become very challenging to even accomplish at all, if it's even possible at all. Same with mining. The current mining technology is going to take a massive hit because those types of vehicles are not going to be able to perform without shorting out constantly, because there's going to be a tremendous amount of overload in energy as soon as those alternators and those generators and all those things kick on. And that brings me to like conventional transportation, regular vehicles. I mean, it is possible to modify a vehicle and go to what you might call a low voltage combustion engine. But there's all kinds of problems with that because the supply of oil is going to be weird. The supply of gas could be very sketchy. And so having that type of vehicle may only be good for a short time. Electric vehicles obviously are not going to perform well in this type of high charged ionosphere environment because those electric motors, the batteries, everything at high voltage is going to attract so much energy into them and overload those systems very quickly. So the idea of like magnetic energy engines in vehicles could become prevalent very fast in order to keep transportation going. Boats are interesting because if you have a smaller boat, like you have an engine on a smaller boat, and you Faraday cage that thing and ground it to the water, you might actually be able to accomplish some. Really, actually, that might work. And so, because you actually have a grounding that protects you from the charges that will be coming through. Let's see, like hospitals, schools, grocery stores, all of that, as long as they maintain as low a voltage through the process as possible, they'll be fine. So like you could still have computers running, you could still have lights running like LED lights, you could have all of those things happening as long as you stay in the low voltage area. It shouldn't be that big of a problem until the transition is made into magnetic technology, and then you can have a whole new world starting to, basically unfold before our eyes, where electricity kind of becomes more obsolete, magnetic energy starts really taking its rightful place, and we transform every part of our lives. And that's kind of what this whole channel has been about. So this is something that we probably probably the government and companies will probably not prepare for this. Now the top secret labs, they're already basically prepared for it, but from an outer conventional point of view, they're probably with no adjustment to the grid and no preparation for this whatsoever. And I'm not really sure what we can do as individuals, other than like you could have smaller solar panels that give you some electricity at like low voltage doses so that you can have certain things keep on running and keep doing it. But as far as like infrastructure and transportation and all that, it could take quite a significant hit for a time. But like I said, manufacturing can still be done in shielded buildings, and it's a lot of this is going to come down to shielding. Like cable, if you have like say cable for internet, that is, those coaxial cables provide a significant amount of shielding. So having information transmitted through those and like low voltage signaling, that type of stuff is probably fine. But here's the thing though, when you have like a Wi-Fi tower trying to really, you've got high wattage and stuff, and it's really pumping out a lot of energy, all of that is not going to work. So any type of like EMF, and this is really weird because even like simple things like the military uses radar, and there's a million different signals around our planet all the time. Radio signals, all of that's going to become just blacked out. Essentially, it will be like fuzzed out. And it's kind of like what happens to shortwave radio when we have a solar storm and it just gets knocked out. It'll be like that, but times that by 10, and it'll be 24/7. Now the good thing about this, I don't want this to sound negative, because this is a very positive change that's happening. And I know this sucks, but when society needs to change, it really needs to change, and sometimes the current system has to collapse in order for that to happen. And this change is not only necessary, it's for our survival, but it's a huge benefit on the other side of it. And it's important. This will give us more energy in our bodies. It will start to transform our consciousness. It's all of this stuff is linked together. And so this process is hugely important that we go through this. The current system is not sustainable, as everybody knows that. But with the breakdown of that current system and the emergence of magnetic energy technology, there will be a new sustainable system that we can actually thrive on this planet. And it will no longer be this struggle for survival and this fighting over resources and all the limitations of energy and power and food and all that. All of that will change with magnetic energy technology and a rising consciousness, and we will be in a place where we're actually doing pretty well on this planet. So with that said, I think I covered everything that I am supposed to cover on this. And if you like this, please hit like. Please send in comments and questions. I know, because this could trigger a million questions, and you don't have to. I mean, if you want to just send them in the email, that's great. But you can also just comment on the video, because that's cool too. Hit thumbs up, subscribe, share the video, all that good stuff. And I hope this wasn't too heavy. It's not supposed to be, because this is a really important transition that we have to go through. But I will see you next time.